So, in the last lecture we started the introduction to the transportation problem, and we have done the northwest corner rule to find out the initial solution of the transportation problem. Let us go through some other methods also. The next method is the row minimum method. In that case, in this case what we will do? We will find the minimum cost cell in the first row and allocate maximum possible amount. Please note, allocate maximum possible amount, that is maximum of this minimum of A I comma B j. Then we apply the same procedure to the shrunken matrix. Shrunken matrix means we will remove that row where already we have allocated and which is obtained from the previous one after deleting the maximal allocated cells row, and we will repeat the process until we are allocating all the rows. So, this is again a simple form, that is, you take the first row, in the first row you choose the cell which has the minimum cost, and then you allocate the maximum possible amount, that is minimum of A I comma B j. Then you delete or remove this particular row from the original table, get the shrunken matrix and repeat the process for all of them. We are considering this problem. We have the costs are given like this. These are the origins O1, O2, O3. These are the destination D1, D2, D3, D4, and here it is the demand and the availability on this side. This side I am having demand and this side I am having the availability. If you see, the sum of these two is 43 here and here also 12 plus 12 24, the 16 plus 12 28 plus 15 43. So, the problem is a balanced problem. So, according to row minima method, what you do? First you choose the first row. In the first row I am finding the last this cell, that is cell 1 comma 4, this cell, that is cell is 1 comma 4 has the minimum value. So, what you will do? You will allocate 11 to this particular cell, right. You will allocate 11 to this one. So, in the first row you are taking, you are finding the cell which has the minimum cost, there you are allocating the minimum of what? Minimum of this availability and the demand, that is minimum of 11 and 15, and you will get 11 over here. So, basically what is happening? You are allocating the minimum of A I comma B j to the cell which has the lowest cost in the first row. Now, when I will go to the next table, I will remove this particular row. So, what I will obtain in step 2, there will be only 2 rows. 2 rows means you will have only second row and third row. First row already we have made the availability, fulfilled it. So, this we will remove. Therefore, you are having 17, 18, 14 and 23. Here you are having 32, 27, 18 and 41. Here it is 6, 10, these will not change, 12, 15, 12 and in this case, this 15, from this 15 we have already allocated 11. So, remaining will be 4. Please note this one, the remaining will be 4. So, that here it will be 4 and here both are there 13 and 19. Now, again take the first row. In the first row minimum is coming on this one 1 3, that is 14. Now, minimum of 12 and 13 availability and demand is 12. So, that you will allocate 12 here. So, this 12 will be 0, this 13 will be 1. So, what I will go in the next step, I will just remove this particular column because already I have allocated here. So, in the next table there will be 17, 18 and 23 will come. For the next one 32, 27, 41. Here it will be 6, 10 and 4 as it is. For this case it will be 1 and 19. So, again repeat the process, minimum of this is coming on this and minimum of a I comma b j 1 comma 6 is 1. So, I can allocate 1 over here. So, this becomes 0, this becomes now fine. So, remove this row again. So, once I am removing this, I will have only one, this one, that is 32, 27 and 41. Once I have allocated here, this I am allocating. So, here it will be 5, 10 and 4, 5, 10 and 4. Minimum is coming on the second cell here and here it is 9. So, since it is 13, 27 and 41, 13, 27, 41, here it is 19. So, in step 4, minimum is the second cell 27 and minimum of 10 and 19 is 10. So, you are allocating 10. So, this will be 0, this will be 9. So, this will be removed. So, in the next stage you will have only 32 and 41. Here it will be 5, 4, it is 9. Out of these two, 32 is minimum. So, minimum of 5 comma 9 it is 0. So, you can allocate 5 here. So, your remaining will be 4. So, now you have only 41, you see on both sides 4, 4 is there, you are allocating this. So, therefore, for the original problem, if you see, you had 21, 16, 25, 13, 17, 18, 14, 23, then 32, 27, 18, 41. From the first one, this cell was having an allocation of 11. So, I am writing 11 here, then I am writing from here 12 will go to this 14, after that 1 will come over here and then here it will be 5, this is 10 and this one will be 4. So, you can check whether all the allocation has been satisfied or not, 6, 10, 12 and 15. So, here 5 plus 1 6, 10, 12, 11 plus 4 15. Similarly, row wise it is 11, it is 13, it is 5 plus 10 plus 4 19. So, it is satisfying your allocation and the condition also summation over A I j equals B I j and the other condition. So, your cost will be how much? Your cost will be 11 into 13 plus 1 into 17 means the multiplication on the allocation into unit cost on the allocated cells only. So, 12 into 14 plus 5 into 32 plus 10 into 27 plus 4 into 41 and the value you will obtain as 922. So, this is another method. These are very simple methods by which you are finding the initial basic feasible solution. The advantage compared to the LPP method, because if you see you can solve the problem by LPP method also. There you have to introduce slack variable, surplus variable, if required artificial variable. You have to find out the initial basic feasible solution like that. But using this particular method, directly you are obtaining the initial basic feasible solution and after this you can check automatically whether that will satisfy the optimum or not. Your next method is the column minimum method. In this method, we just make the opposite of the row minimum method, that is we find the minimum cost cell in each column and allocate maximum possible allocation to it. So, instead of row wise operation, here basically we perform the column wise operation and then we remove the corresponding column and allow the method to the or apply the method to the shrunken matrix as we have told earlier. So, here see the problem. Here the problem remains same, because we will work with the same problem and we will see what kind of results we are getting. So, you have to see the first column first. This is the first column. First column, the lowest cost cell is coming on 1, 2 comma 1, that is where cost is 17. Now, minimum of availability and demand is 6, 6 comma 13. So, you will allocate 6 to this one. So, once you are allocating 6, this will be 13, this will be 7. So, now what will happen? The first column you will remove and you will shrunken the first column. Means now this column will not be there, you will write down only these 3 and the new allocated values. So, in the next table what you will obtain is 16, 25, 13, 16, 25, 13, 18, 14 and 23, 27, 18 and 41. Your allocations are, in this case it is 11, 7, 19 here, this is not there. So, on this side it will be 10, 12 and 15. So, you are writing this 11, 7 and 19 and here it is 10, 12 and 15. Now, again you take the first column. In the first column minimum is coming on the 1 comma 1, that is first cell. So, minimum of 10 and 11 is 10. So, you allocate 10 over here. Once you are allocating 10 here, this reduces to 1 and this is 0. Now, in the next iteration this particular column will be going out. So, that you will obtain 25, 13, 14, 23, 18 and 41. Here it will be 1, 7, 19 and these two will remain 7, that is 12 and 15. So, therefore, your again take the first column, minimum is the second cell here from this one and the minimum of 7 comma 12 is 7. So, allocate 7 to this. So, this will be 0 and this will become 5. So, now you remove this one, so that you will obtain 25, 13 and the last row 18, 41 and the allocations will be 1, here it is 19, here it is 5, here it is 15. Now, again on the first column minimum is the second cell, that is where cost is 18 and minimum of 5 and 19 is 5. So, allocate 5 here. So, this will be 0, this will be 14. So, now only this column will come. So, that you are writing 13 and 41, where you are having 1 and 14 and this is 15. Minimum of this is 13. So, allocate 1 over here, this will become 0, this will be 14. So, only one cell is remaining, that is 41 and where demand and the availability are same. So, you allocate this thing. So, therefore, your original problem is 21, 16, 25, 13, 17, 18, 41 and 23, 32, 27, 18, 41 and it is 11, 13, 19, here it is 6, 10, 12 and 15. What are the allocations? For the first time allocations was here 6. So, here you are writing 6, then you will get it from subsequently from the next steps, that is 10 here, then after that you got the 7, 7 got it, sorry, this is 14, 7 here, after 7 you are having 5. So, 5 is coming on 18 side, after that you have 1 is coming with 13. So, 1 will come over here and the last one is 14. So, this is your allocation. You see it is 6, 10, 7 plus 5, 12, 14 plus 1, 15 and row wise also 10 plus 1, 11, 6 plus 7, 13, 5 plus 14, 19. So, the allocation is satisfying the condition. What will be the cost for initial allocation? As usual, you will calculate the cost on the occupied cells only, that is 10 into 16 plus 1 into 13 plus 6 into 17 plus 7 into 14 plus 5 into 18 plus 14 into 41 and total cost you will find 1037. Although, for the same problem, if you see earlier case, for the earlier problem case it was 922. So, as we are telling, you will obtain the optimum, you will obtain the feasible solution, but that may not be the optimum. We will come to that one. The next method which we will use, that is matrix minima, or which we call as least cost entry. In the list, in this method, the cost matrix is inspected thoroughly. That means, we do not see either a row or column. Instead of that, we check all the cells, and the cell with minimum cost is chosen for maximum possible allocation. That is, we do not see either a single row or single column. We see all the cells of the matrix, and we choose the cell which has the minimum cost. Please note this one, which has the minimum cost, and you allocate maximum. Then the row and column whose capacity or requirement is exhausted is deleted from the table, and the process is repeated for the shrunken matrix as usual, what we have seen for the earlier two cases. Now, if the minimum cost cell is not unique, then you can choose any one of such cell which can be selected arbitrarily, and we have to check that cells corresponding to the feasible solution or a subset of such cell will not form a loop. Only thing we will see this we will discuss afterwards, why we are talking about this one. So, let us take the same problem again. On the same problem, what we find here, the minimum of all the cells is coming on 13, this one, minimum cost for all the cells of the matrix is 13. So, allocate this on this cell, how much is minimum of 11 and 15, which is 11. So, you are allocating 11 over here. So, that this becomes 0, this becomes 4. So, once I am allocating the full, this row will, first row will be removed, and you will get the shrunken matrix is this one, that is 17, 18, 14 and 23, 32, 27, 18, 32, 27, 18 and 41. Here it is 0, you will get 13 and 19. For this case, you will get 6, 10, 12, where the demand has reduced to 4. Now, once I am doing this thing, again find the minimum of all these things. The minimum of all the cells is coming at cost 14, cell 1 3. So, the minimum of 12 comma 13 is 12. So, allocate 12 over here. So, that this will become 0, this will be 1. So, that remove now this column in the next iteration, this column, because our demand is satisfied. So, in the next one, from here it will be 17, 18 and 23, then 32, 27 and 41. In this case, it will be 1 and 19. Here it is 6, 10, this column will not be there, and 4, 6, 10 and 4. Now, minimum of this is 17 and minimum of 1 comma 6 is 1. So, that you are allocating 1 and you are making this as 5. So, since I have allocated fully, so now there will be only one row, that is 32, 27 and 41, and here it is 19, this allocation will be 5, 10 and 4. Minimum of this is 27. So, I am allocating minimum of 10 comma 19, the availability and demand 10 over here, and this will be 0, this will be 4. Now, this column will be removed and I will have only 2 cells which will contain 32 and this 41. So, in the next one from here, if you see, from here you are having 32 and 41, where it is 32 and 41, here it will be, sorry, 10 has removed. So, this will be not 4, but 9. So, here it will be 9, here it is 5 and 4. Minimum of 32 and 41 is 32 and minimum of 5 comma 9 is 5. So, 5 will be allocated on the first cell. So, it will be 0, this is 4. I have only one cell remaining 4 and 4 and I am allocating 4 here. So, this is 0. So, the allocation is over. So, what is the final allocation in this case? The final allocation in this case I can write down on this itself to save some time. This is 11, this will be 1, this is 12, then this will be 5, this is 10 and this is this one 4. From these allocations I can write down. If it is clumsy, then I am just writing the allocations at the respective cells. I am not writing the costs. 11, here it is 1, in this cell it will be 12, then here it is 5, 10 and here it is 4, 11, 13 and 19, 6, 10, 12 and 15. And I am just writing the cost associated here, so that you can find out the total cost. Here it is 17, here it is 32, 27 and 41. So, you can check that the allocation is correct. 5 plus 1 6, here it is 10, 12, 11 plus 4 14, here it is 11, 12 plus 1 13, 5, 10, 14, 19. If you calculate the cost, total cost, your total cost will be equals to 11 into 13 plus 1 into 17 plus 12 into 14 plus 5 into 32 plus 20 into 27 plus 4 into 41, and you will find that the value is 812, corresponding to the earlier case which was 1037 or 922, or in the earlier case for this problem it was 922. So, the cost has reduced in this case. Please note this one, that the cost has reduced. Now, we are emphasizing on this point, that by these methods I can obtain the initial basic feasible solution, just like we got it for the linear programming problem, but that does not ensure that the cost will be optimum. So, all these methods are used, but in these cases I am finding that the cost is not optimum. So, one more method was developed after this, which is actually being used to find out the initial basic feasible solution. This we call as Vogel's approximation method to find out the initial basic feasible solution of the basic problem. So, in Vogel approximation method is an improved version of the matrix minima method, but it may not always produce the better BFS solution. It does not guarantee. We have to find out the method by which I can check it produces the better solution. So, it is not only considers the least cost, but also the cost which exceeds Cij. Let us see the method. In step 1, for each row or column, determine a penalty cost by subtracting the smallest unit cost element in the row or column from the next smallest unit element in the same row or column. So, basically for each row or column we are determining a penalty cost by subtracting smallest unit cost in that row from the next unit cost. We are calculating that. In step 2, we are identifying the row or the column with maximum penalty. If tie occurs, if there is a tie, then we choose it arbitrarily. Allocate as much as possible with the least unit cost in selected row or column. If a row or column is satisfied simultaneously, only one of them is crossed out and the remaining row or column is assigned 0 supply or 0 demand. In the next step, what we are doing, if exactly one row or column with 0 supply or demand remains uncrossed out, then stop. If one row or column with possible supply or demand remains uncrossed out, determine the basic variables in the row or column by the least cost method and then stop. If all the uncrossed rows or columns have 0 basic variables by the least cost method, then also stop. Otherwise, you go to the stop one. So, this is the basic idea of the Vogel's algorithm for the Vogel's approximation method. So, what we will do in the next class, first again briefly I will talk about this Vogel approximation method. I will explain the Vogel's approximation method with certain examples.